Welcome to Get Preparation. Today we will solve question number 37 from GATE 2021. The question is given as the major products P and Q formed in the following reactions respectively are. So here you can see this compound is treated with this sulfoniamide to give product P, and it has been treated with the sulfoxoniamide to give product Q. So before moving to the solution part, let's have a look at the basic concept behind this question. So how we can prepare the sulfurilides and what kind of stability they possess. So when this sulfonium is treated with sodium hydride, it can give the corresponding sulfoniamide, or simply we can say sulfurylide. Now this sulfurylide can be stabilized through conjugation with sulfur. So this negative charge can be stabilized through conjugation with sulfur. So due to presence of the d orbital of sulfur, it will be stable. Now when this dimethyl sulfoxonium is treated with sodium hydride, it generates the corresponding carbon ion. Now when this carbon ion is treated with this sulfonium, it can also produce the corresponding sulfonium ylide and dimethyl sulfoxide. Similarly, instead of this sulfonium, if we take the corresponding sulfoxonium ion, then in presence of this carbon ion, it can generate this sulfoxonium ylide. So this is sulfoxonium ylide. So this also can be stabilized by the d orbital of this sulfur. Now if you see the reactivity of these sulfurilides, both the sulfoniamide and sulfoxoniamide can undergo nucleophilic addition with this carbonyl, and it can produce the corresponding epoxide product. So we can take the sulfoniamide and we can see the mechanism how it can form. Suppose this is the compound. Now if you treat this with this ylide, so first it can attack here, then it will give this intermediate semi2 plus. Now it will attack here and dimethyl sulfide can be eliminated, and we will get the corresponding epoxide product plus dimethyl sulfide. Now so here you can see the difference between phosphorus ylide and sulfur ylide. If you treat this compound with phosphorus ylide, we will get the corresponding alkene product. Why? Because if you treat with this, or we can write like this, So now if it attack here, So minus is CH2 and PPH3 plus. What will happen? Instead of attacking here and this triphenyl phosphine gets eliminated, as phosphorus oxygen bonds are very strong, this oxygen will form bond with phosphorus and eventually this triphenyl phosphine oxide will be eliminated. We will get this alkene, CH2, and triphenyl phosphine oxide will be eliminated. So this is the basic difference between phosphorus halide and sulfur halide. Now this sulfonium and sulfoxonium can react in different manner in presence of alpha beta unsaturated carbonyl compound. So what does that mean? So if we treat this compound with sulfonium we will get one product. If we treat this compound with sulfoxonium we will get different product. Now which halide will give which product? Which halide will give epoxide and which halide will give cyclopropane? So basically the addition of sulfonium means Me3 Me2S plus CH2 minus, this is our sulfonium halide. The sulfonium halide addition on carbonyl group is irreversible. So what will happen? This sulfonium halide will attack on this carbonyl group and it will give the corresponding kinetically favorable product. That means we will get the corresponding epoxide product. But when we will use the corresponding sulfoxonium halide, now the addition of sulfoxonium halide to this carbonyl carbon is reversible process. As a result, eventually this halide will prefer the addition over this position. That means it will prefer Michael addition, and through Michael addition we will get the corresponding cyclopropane product. How it will form? So it will attack here. From here we will get this intermediate CH2 H double bond O Me2S. Now come back here and this pi bond will move here and dimethyl sulfoxide will be eliminated. So we will get cyclopropane here, double bond, plus Me2S double bond O. So what is the conclusion then? In presence of sulfonium halide, we get the corresponding epoxide product. In presence of sulfoxonium halide, we get the corresponding cyclopropane product due to kinetic and thermodynamic control. Now let's move to the solution part. So here this compound is treated with sulfonium halide and sulfoxonium halide. Now the thing is, the sulfur halides doesn't react with this isolated alkene. So it will react with this moiety. So as we have already seen, the sulfonilamide prefer kinetically controlled product and it gives the corresponding epoxide, so we will get this product. And as sulfoxonilamide prefer Michael addition, so it will give the corresponding cyclopropane product. So this is P and this is Q. So let's see the options. So as we have seen, P contains epoxide. So here P contains cyclopropane. So this is not the correct answer. Here P contains the epoxide and Q contains the cyclopropane. So option B is the correct options. And as all these are reacting at this alkene position, this cannot be correct option. To know about these sulfurilides in detail, please do watch the lecture series Principle of Organic Synthesis by Professor T. Punyamurthy, Department of Chemistry, IIT Guwahati. Especially lecture 26, where he discussed about reactions of sulfur and silicon containing reagents. Thank you.